So, welcome to the first lecture on uh, physical oceanography. So, there will be a series of lectures in physical oceanography. So, this is physical oceanography 1. Now, Earth, it may be noted, it is essentially a water planet. Earth is essentially what is termed as water planet. So, that is most of the Earth's surface is covered by most of the Earth's surface is covered by water. So, most of Earth's surface is covered by water. So, water is a very important ingredient in the elements which make up or the constituents of the earth. So, in fact, it is water is also water actually came to the surface, water came to Earth's surface because of its rotational movement. And water, as you know, it being lighter than the soil or the rocks which make up the earth. So, it started floating on the crust of the earth, it came to the surface. Now, 71% of the earth's crust, so actually the amount of coverage is 71% of earth's crust. So, you will be surprised to know that 71% of earth's crust is covered with water. Now, average depth of this water mass is 3.73 kilometers. So, that is the average depth of the oceans. So, we are confronted with a sort of cover over the uh, crust of the earth. Now, this major amount of water, major amount of this water mass, this is present in namely in 3 bodies. So, this is present in 3 bodies. So, namely that is in first is atmosphere, sorry, major amount of this water mass is present in oceans, you can write. So, there is a small mistake, it is present in oceans and smaller amounts. So, these smaller amounts are present in atmosphere. Then lakes and glaciers. So, the large portion of this 71% of the earth's crust is covered by the oceans and the smaller amounts they are to be found in atmosphere, lakes and glaciers. Now, because of this large water mass, so almost which is covering 71% of the earth. So, ours is a water conditioned existence. So, water conditioned existence. So, that is mankind cannot live without water. So, ours is basically a water conditioned existence. Mankind, obviously everyone knows, cannot live without water. So, this is the first inference from a water conditioned existence. So, we cannot live without water, that everybody knows. The other most important thing is that this huge water mass, is huge water mass. So, this is very important. This huge water mass, 71%, influences climate. So, this affects all of us. So, there are two important things. One is the source of water for the mankind, which is supplied from lakes, rivers, oceans to some extent, and the influence of this water body of the oceanic waters on climate. So, this is very crucial. Climate actually influences the the lives of the people, not only mankind who are living along the coast, but also inwards. So, coastal life, coastal life is very much influenced by coastal life, very much influenced by sea breeze or wind from the oceans, wind from oceans. So, the coastal climate is very much distinct from climate which is more landward or inside the land or continental climate. So, this is the direct influence of the ocean on the climate. So, this is one important difference which most of us will find. So, climate is influenced by the oceans. Now, we are starting our these elements of ocean engineering with thank you, with the physical oceanography, which the meaning of this term physical, or rather physical oceanography means the features, or rather it is the physical features of the ocean. So, what are the, we should know what are the physical features of the oceans. So, oceans, on the top we can see that there are waves. So, that is visible to the naked eye, but if we go to the depths of the ocean, there of course, there will be no waves. So, there we will find the physical features, that is the ocean floor, the ocean bed, sea bed, etc. What are the features? So, those will influence the those are called the physical part, coming under the term of physical oceanography. So, physical oceanography is very important if one has to do anything in the ocean. Now, before we go deeper into this subject of physical oceanography, so we should have a look into what is the nature of the earth. So, this I think is covered in most of the geography books. So, you will find the physical nature of earth. So, one has to start with the physical aspects of the earth itself in order to have a deep gross understanding of the oceans. So, actually we cannot, the earth is comprised mainly of the continent, that is your continental crust, and the oceans or the oceanic crust. So, in that way the you will be surprised that the earth is also not stable, earth is actually spinning on its own axis, and because of this it is causing the lot of motions in the oceans. So, that one will come across the Coriolis effect and all that, one has to study that. So, those create circulation in the water mass, that is your currents. Now, besides this you will find that coming to the physical nature of the earth, that is the what are the physical properties, you can the earth actually you will be surprised is not exactly round or exactly circular in shape, but it is somewhat elliptical. As you can see from this figure, there is the inner one is called the core, and on top of this core you have a cover or a mantle. So, this is called a mantle rock. So, here from this diagram you can observe that the core is very securely ensconced inside the mantle rock. So, this is the basic physical nature of the earth. Of course, I am unable to draw this is somewhat circular, but you see along the hemisphere or near the equator there is what is called a bulge. This the figure is somewhat, since I am drawing by hand, is not coming, but it will have a bulge near the equator. So, that is called a equatorial bulge. So, because of the rotation of the earth and the rocks, because of its because of the centrifugal forces, it tries to go outside from the center of the earth. So, that is called the equatorial, this is called the equatorial bulge, and inside this you will have a core. So, this is core rocks. So, this is essentially consists of metal. So, this is metallic iron. So, the core consists of a iron. So, metallic iron, and this core actually essentially gives the earth its magnetic properties. So, magnetic properties of the earth, that is the sorry TIES. So, magnetic north, magnetic south, the magnetic axis. So, earth is essentially a magnet because of the metallic core. Now, on top of this metallic core you have the shroud, which is called a mantle rock. So, mantle rock actually covers the core. Now, on top of this, now this is a huge rock mass, and on top of this you have the, this is we are mostly interested in these two types of crust. So, you have a continental crust. So, there is proportional to the mantle rock, you will find this is called a the continental crust. Now, from this diagram you can see that this continental crust is actually floating on the mantle rock, and if one wants to know the what is the radius, the equatorial radius is 6378 kilometers. So, this is near the equator, and so I told you that there is a equatorial bulge. So, because of this bulge, the radius at the equator is somewhat more than the radius at the poles. So, you are at the poles you have, or the polar radius is slightly less. So, this is 6357 kilometers. So, you can see there is the difference in the radii of the earth. So, 6378 and 65, although it is very small, but it is still there. So, from this we can find out that is the radius of the core is itself 3498 kilometers. So, in the core radius, so this is 3498. And the mantle thickness is 2880 kilometers. So, you can see that the core is actually the radius is more than the thickness of the mantle, but mantle rock is also quite significant. So, so here we find that the continental crust is essentially floating on the mantle rock. Now, the part of the continental crust which goes into the ocean, it forms another crust which is called oceanic crust. So, this oceanic crust is relatively young, that means it has grown from the continental crust. So, this continental crust is the depth, there is the depth is 35 kilometers. So, this is the layer of the continental rocks. That means, the rocks which make up the continent, the depth is 35 kilometers, whereas the oceanic crust which has been formed relatively new or young. So, we say that this is the oceanic crust. But the thickness of this crust is very less compared to the continental crust. So, oceanic crust is only 7 kilometers in depth, only 7 kilometers. Now, oceanic crust is there also rocks, continental crust is also rocks. Now, these do not consist of any water mass. So, these are rocks and these are also rocks. So, on the mantle rock we can divide the continental crust and the oceanic crusts. So, now if you take the percentage wise breakup of this mass, you will find mantle rock constitutes 68.1% of the mass of the earth. So, these are the mantle rocks. So, mantle rocks constitute 68.1% mass. So, next we come after this is the core rock or the core. Now, the core constitutes of 31.5% of the mass, the total mass of the earth. So, these are if you add this, so most of the mass of the earth, so this comes to 99.6% is made up of rocks. So, 99.6% of the earth's mass is made up of rocks. Now, what remains is the rocks which are not covered in the mantle or in the core. So, they form what is called the rocks of the continents. So, that is constituting your continental crust, which is floating on the mantle rock. So, core is, you can see from this diagram that this core is different from the mantle, and on the mantle also you have the continental and oceanic crust. Now, see this together. So, we can write that rocks of continents and ocean basins. Now, basins is the lowest, basin means it is the lowest part of the ocean, that is the horizontal plane right at the bottom of the ocean, that is on the sea floor or on the ocean floor. So, that is called the ocean basin. So, rocks present on the continents around the ocean basins plus the waters in the ocean. So, we can write ocean waters, plus water in atmosphere. So, water in an atmosphere, now these constitute only 0.4% of the total mass of the earth. So, if you one adds 99.6 plus 0.4, we get the total mass, that is 100% of the mass. So, here from this breakup we can see the earth actually constitutes, a large part of the earth is constituted by the core and the mantle rocks. Only a small part of the mass, that is hardly 0.4%, is occupied by the continents and waters. Now, the core that I have told you, that is the core of the earth, is essentially made of iron. So, which the core gives us the magnetic properties. So, this I think I have already told you. The magnetic field of the earth is generated by the core, magnetic field of earth. Now, this is used in where this is very important from our point of view, those of us who are studying the ocean engineering. This magnetic field is used in what is called, later on we will come to know, this is called magnetic survey. Magnetic survey methods by which one finds out the amount of oil in the reservoir and the nature of the rocks, etc. So, that uses the magnetic properties of the earth, which are generated from this, essentially the iron core. And the other survey which utilizes the mass, that mass of the earth consists of this mantle and the core rocks. So, that gives us the gravimetric field. So, gravimetric field. So, now there are very sensitive instruments which studies the nature of the gravitational field generated by the earth, the mass of the earth. So, gravimetric field is generated, and this gives us what is called the gravimetric survey. So, these are two important survey methods which are used in ocean engineering. So, gravimetric survey. Now, there are in order to survey the oil, survey I mean essentially we are more our point of interest or our major area of interest is in order to gauge the quantity of oil in the reservoir. Survey means explore oil in reservoir. So, this is very important for the that if one goes into the ocean engineering. So, one now since drilling for oil is very costly and it is also a time consuming affair. So, one has to before takes the decision to drill for oil below the sea surface, one has to have a map of the oil reservoir. So, this is done by both the gravity survey, gravimetric field and also the magnetic survey. And after this is done, there is another survey which is called seismic survey. So, this actually there are explosions. Seismic means explosions are generated on the sea floor and the return path of the sound is measured. So, this is in a nutshell what is called the seismic survey. So, before one any company or anybody who goes to drill for oil, he must satisfy himself that whether by all these three surveys, that is your gravimetric survey, your magnetic survey, then seismic survey, that the oil in the reservoir is exploitable, that is it is economically feasible to extract that amount of oil from the reservoir down below the ocean surface, which is of course is a very costly affair. So, when one ventures out into the sea or one tries to explore oil, so previously one has to undertake survey, and then after this survey procedure is completed or finished, then you try to dig out or try to take out what is called the soil samples and explore the chemical composition of the soil in order to make yourself more certain. So, this is the point which I wanted to stress in physical oceanography. So, these are the parts of the earth. So, you have the equatorial bulge and then the mantle core rocks and continental and oceanic crust. Now, here you will find that so previously I have told that these continental and oceanic crusts, if you can see from this diagram, that they are essentially floating on the mantle rock. So, that means they are not fixed. First of all, you see the earth, if one wants to know, there is always changing, its position is always changing with time. First of all, it is spinning about its own axis, and also it is going around the elliptical path with the sun as a on the one of its foci. So, it is always changing. So, the continental crust also it is not fixed to the mantle rock, but it is floating. So, this also there is movement on the continental crust. So, also the oceanic crust also there is movement. So, those are not, so you will be surprised to know that these are not static, but these are actually floating, and one crust they also can go against the movement of another crust, and then you will have, so earthquakes will emanate and volcanoes and all these things will go on. So, there is a dynamic situation which one faces when one studies the what is called in plate tectonics. Of course, this is the realm of the geologist or the seismic engineer, but because of the movement of the crust. So, essentially this is movement of the crust. So, this is another branch of study in seismology. So, plate tectonics. So, because plate tectonics has come because of the movements of the continental and the oceanic crust. So, that is a separate branch. Now, here actually if one studies the continental crust, we can see the reason I told that it is floating on the mantle rock. So, one will find that where you will have large mountains if one studies on the continental crust, that is on the land, and below this you will find a large portion which is below the mantle, which is going deep inside the mantle rock. So, this is your continental, this is the continental crust. And because the continental crust is floating on the mantle rock, so this part actually is below the mantle rock. Why? The reason is wherever you find the large portion of the continental crust protruding above. So, it has to be supported by buoyancy. Since this is floating, any floating body has to be supported by buoyancy. So, this because the continental crust is more here. So, the rock formation which goes below inside the mantle, that is the continental rock, is also deeper because of the increased weight in this region. So, this is why the depth will be more here rather than the depth here. So, here of course, you can see, one can see that the layer of the continental crust is rather thin, but here it is thicker or more. So, here it has to be supported more by more of the buoyancy force, and this can only be achieved by larger sinkage of the continental crust. So, here we can see the depth more. So, this is one example to show that the continental crust is floating on the mantle. So, here the continental crust, it has come thinner and it is going outwards. So, this is called the oceanic crust. So, continental crust actually expands towards the sea. Now, here actually towards the land, of course, it does not have any room to expand. So, it can only be expand towards the sea, and that is one of the reason why the oceanic crust is younger than the continental crust. So, one inference we can get from this diagram is that oceanic crust, now in the oceans you will not find, one does not find large mountains. So, that is why the oceanic crusts are relatively shallower than the continental crust. So, oceanic crust is younger than continental crust. So, this is one important inference we can have from this. So, this is coming to the rock formations on the continental crust and also on the oceanic crust, and this ocean, that is the ocean, what if we measure it relative to the depth of the continental crust, that is your the mantle rock and the continental and oceanic rocks. So, it is the mantle rock which one can observe from this diagram is 3498 sorry, this is 2880 kilometers. Now, compared to this, the oceans, that is the depth of the oceans is hardly, the average depth is hardly from 3 to 4 kilometers. So, ocean is basically is a thin film of water. Ocean is a thin film of water. Now, if one acquires the data, the area or the spatial data, so one finds out that the Earth's surface, so Earth's surface is 510 into 10 to the power 6 square kilometers, or rather I can write kilometer square, whereas the ocean surface, so this is 361 into 10 to the power 6 kilometers square. So, this I think the average, I think one if you work out. So, this is 71% of the total Earth's surface. 71% of, I think 510 will give us somewhere near this 361 figure. Now, the average ocean depth, so average ocean depth, so this is 3.73 kilometers. So, with this the 361 kilometer multiplied this by 3.73. So, one can get a rough idea of the water mass. Now, the hydrosphere distribution or the water distribution, the total water distribution, if we can break down, this is called hydrosphere distribution. No, actually for our case, that is the ocean engineer is only for his knowledge, but he need not do detailed study on the amount of the seawater and the water in the lakes, rivers, oceans and the dynamics, etc. So, those are taken care of by the meteorologists and the those who study the circulation patterns of these water mass. So, they are more interested in the relative masses of these water. But anyway, just to have one's curiosity, just to for curiosity sakes or for information sakes, you can write the seawater is 1410 into 10 to the power 15. So, this mass is given in tons. Now, the seawater is the maximum percentage, if you can see from this chart. So, this is percentage wise, this constitute 86.5% of the hydrosphere. Hydrosphere is the total water inside the earth. So, seawater constitutes 86.5% of the total water mass. Next is your lakes, water in the lakes and rivers. So, the total mass is very small compared to 1410 or 1410, this is only 0.5. So, this 0.5 is 10 to the power 15 and this constitutes only 0.03% lakes and rivers. Now, next you will be surprised that continental ice. Now, what is this continental ice? So, this continental ice is the ice in the Arctic and Antarctic regions. So, those are the continental ice and they make up a substantial amount of the water mass. So, this is next to your seawater. So, this is 22 multiplied by 10 to the power 15. So, this is percentage wise, this is 1.3%. So, you can imagine that the continental ice present on the poles is more than what is present in our lakes and rivers. So, if this huge water mass melts, somehow those of us who are now afraid of global warming, so they can increase the water in the oceans. So, next is the water after continental ice, one comes across the water vapor. So, water vapor in atmosphere. So, this atmosphere besides your air, it has water vapor, and if the water vapor is saturated, then of course, there is precipitation or rainfall. So, this also this is 0.013. So, all this is into 10 to the power 15, and this is only 0.001%. Then after this is the water in the sedimentary rocks or water in sediments. Sorry. So, sediments is on the sea floor or below the lakes and rivers, sediments. So, these are also quite substantial, that is this is somewhat 200 multiplied by 10 to the power 15. So, this is 12.2%. The total if you make up, so this is 100%. So, from this chart one can see that the maximum amount of water is in the seas of course, and then next is water in sediments. Continental ice is also substantial 1.3%. So, water in sediments actually for us, for the ocean engineers, this is also very important, because of the reason is, that is, if you want to have any foundation on the ocean itself or on the sea, then one comes across one has to do foundation in the which is sediments which are saturated in water. Foundation has to be designed on, or structures have to be designed in the ocean on sediments which are basically saturated with water. Unlike in land, you may have dry sediments, but in the oceans it is wet sediments or saturated sediments with water. So, these are the two types of sediments which you find is different from land and water. So, the total mass you can write down, you can add up all this, and this comes to 1632 multiplied by 10 to the power 15. So, this is the hydrosphere distribution. So, this is just for our knowledge, and the other part that I wanted to tell you is the distribution of these ocean waters. You will find that the northern hemisphere, that is the portion of the earth which is above the equator. So, that is the northern, northern hemisphere. Now, in northern hemisphere, it is essentially a land hemisphere. There is most of the continents of the earth, they are located in the northern hemisphere. So, this constitutes 67% of the land. So, the northern hemisphere is 60% of the land, whereas the southern hemisphere is absolutely a water hemisphere. So, in the northern hemisphere, the 60% of the 67% of the northern hemisphere area is covered by land. Now, in the southern hemisphere hardly you will find land. So, essentially the southern hemisphere is a water hemisphere. Now, there is no land between 40 degrees. So, between 40 degrees to 65° south latitude, there is no land. Now, because of this reason, at this between the 40° and 65°, there is a huge amount of ocean current which causes a global circulation. So, there is a strong oceanic circulation. So, this is called the roaring forties. So, if one visits the Antarctica region, near the Antarctica, you will come across the roaring forties. So, that means this region is very active in the as far as wind and currents are concerned. So, these are called the roaring forties, and they cause a global circulation, and this actually influences global climate. So, this current is called the roaring forties. So, this is the ocean circulation influencing world climate. So, this is just an example. Now, if one wants to go further, then the oceans can be divided into number of parts. So, oceans Atlantic, then you have the Indian Ocean, then Pacific, Arctic, and last is your the Antarctic. So, these are 1, 2, how many 3, 4, 5, 3, 4, 5. Now, for our geophysical study or oceanographic studies, actually these 5 oceans can be clubbed together into the 3 oceans. You can combine these water bodies into Atlantic for study purpose. You can write this Atlantic, then Indian and Pacific. So, these 5 oceans can be combined and can be segregated only 3 oceans, this is Atlantic, Indian and Pacific Ocean for our oceanography or ocean engineering studies. Now, this is areas and depths of oceans. So, that we have already divided these 5 oceans into the 3 oceans. So, we will write only the 3. So, first is your Pacific. So, the water area, now the water area is given in 10 to the power 6 kilometers squares. So, Pacific is 180. So, it should be come down, and next is your Atlantic. Atlantic water area is 107, and the Indian Ocean is smaller than the Atlantic. So, this is 74, and total world ocean you have 361. So, this gives us the coverage of the Atlantic, Indian and the Pacific Ocean. Now, the land area, that is the coastal area, land area drained. So, this is also in 10 to the power 6 kilometer square. So, the adjacent land area is 18 and this is 67 and this is 17. So, land area affected by these oceans are 18, 67 and 17, and if one takes ratio of water is to land, the area wise. So, this will give 180 by 18. So, this is 10. So, this is roughly will be 1.6 times and the water is to then this is 4.3. So, from this diagram we see that the Pacific is the largest water area with respect to the land. Next is the Indian Ocean area. So, Indian Ocean area we have the continents, that is a large portion of our coast are affected by the ocean waters. Of course, Atlantic is area wise it is less. Now, average depth if one comes across. So, average depth is the Pacific is 3 this is kilometers. Average depth in kilometers is 3.94, then it is 3.31 and this is 3.84. Now, we can see that this ratio of water is to land. So, here you can add this will be 3.6 and this is 3.73. So, our country actually large portion of the coastal area is drained by the Indian Ocean. So, that we should not neglect, and also the average depth is also quite high, 3.84 it is almost near the Atlantic. So, this gives us some of the physical aspects, and coming to the age. So, age wise, so the earth is 4.5 billion years old. Now, oceans I told you it is relatively younger. So, this is only 3 billion years old. Now, these bottom waters they come to the surface. Now, this is to be noted is the circulation of the waters depth wise. So, they come to the surface in 1000 to 2000 years. So, this is bottom water circulation. So, this causes what is called ocean water mixing. So, this if one divides the age is 3 billion years. So, this is 3 multiplied by 10 to the power 9, and average of 1000 to 2000 you take 1500, let us say take 1500. So, this is 2 into 10 to the power 6 times. So, this is not small. So, in the total age of the oceans there has been 2 into 10 to the power 6 times of mixing. Now, coming to the divisions of oceanography. So, here now is you can divide into physical. So, the one that we are studying right now is called physical oceanography. So, that deals with the physical features of the oceans and also properties of seawater plus physical features of ocean. So, this part is discussed in physical oceanography. Then of course, there is another part of oceanography which is dynamics of the free surface, that is the waves and all that. This comes under dynamical oceanography. So, this basically deals with the waves, etc., waves, current. Now, after this one has geological. So, geological oceanography. So, this deals with the origin and evolution of the world's oceans, and chemical is chemical is chemical ingredients or chemical transformation. So, the manganese nodules are caused by the chemical reactions in the sea water. So, those come under the category of chemical oceanography. So, then of course, there the marine life is covered under biological oceanography, and biological other part is biological and pharmacological. So, this last part is deals with the medicinal drugs. So, biological is marine life, so that is fishes. The pharmacology is medicinal plants. So, these are some of the branches of oceanography that one deals with, and then of course, the other the technology part has also developed from this from oceanography. Then the technology part, that also comes under the after 19 say 70s onwards, it has developed very rapidly, that is shipbuilding, then you have ROVs, remotely operated vehicles, submarines. So, these have all developed, then ocean instrumentation. So, these are the technological part of the ocean engineering. So, this is called ocean technology. And at the last we will find maritime regulations. Yes. So, this deals with the law of the sea. So, these are the various divisions of physical or rather oceanography that one comes across. So, thank you. So, next class we will look into the deeper other aspects of the physical oceanography.